Okay, so now is the time to talk about operations, troubleshooting, and visibility. Um, if you're interested to dive deeper into operations, we do have our cloud operations course that mainly focuses on data operations, how to find the issues, how to fix issues, how to use things like FlowIQ, how to solve problems pertaining to firewalls and all of the other modules that we have been discussing. So some of the operational challenges in the public cloud is it's obviously a harder problem to solve because number one, you are operating on an overlay because you do not actually own the underlying network. You do not know who is the neighboring VM. You do not know if there is a problem in the underlying network. You cannot see all of those, right? And many times you are left with what the CSP actually announces whenever there is a problem and the visibility they provide within their tooling, which makes, again, troubleshooting, especially if you're coming from a pure networking background, a bit different and much harder to deal with. There's obviously an unfamiliar tool set, meaning, first of all, we need to remember that, for instance, the underlying VPC or VNet or VCN router is an object that you cannot get into. It's an object that is only accessible to you via route tables and some of the attributes that the CSPs expose. You're not able to get into that. You're not able to do packet captures. Now, in some of the CSPs, you are able to do packet captures, but not the easiest of things. You will need generally to spin up another instance and then to do packet captures. And there are a few things that deal with the performance when you're doing that. Another thing, I mean, this makes it much harder for a network or security engineer that is used to troubleshooting on-prem in data centers with this unfamiliar tool set. Yeah, I think black box or no visibility. Yeah, you generally will. I mean, CSPs want you to trust and consume the objects and resources they expose, and as long as everything is fine, it's perfect. But when things start to deteriorate, or when an app starts to be slow, or you're having challenges, you are limited in a way with the logs and whatever is possible that you can expose, and you cannot really go and get to the underlying network and maybe push more bandwidth. I mean, there are certain things that you can do and certain things that you cannot do just because you are operating in the CSP. So infrastructure as code is a reality. It's not really an operational challenge, but it's a reality in the public cloud, and it's one of the main drivers why customers adopt public clouds. Reality is infrastructure as code solves the speed of deployment, solves the agility problem. However, most people, whenever you talk about DevOps, they're interested in the dev part, but nobody's interested in the ops part, right? So though infrastructure as code being a great pillar and is something we adopt as a Aviatrix and we fully believe in with our multi-cloud Terraform provider, our view is that having infrastructure as code does not help you troubleshoot networks faster, does not provide you the tool set in order to figure out what the root cause of that issue is. Okay? So the other challenge that many network engineers and security ones coming from the on-prem side of the house to the public cloud see is the lack of hierarchy. Meaning, for instance, once I was working with an organization in the Middle East where they had 40 physical firewalls in their data centers. And they had all of these different zones and tons of firewalls and load balancers and security appliances. Whenever you look at a public cloud, generally there are two notions. There's the public subnet and the private subnet. And you need to insert security in this context and leverage a lot of policy-based routing, load balancers, and different mechanisms to get the traffic to be service chained through all of these devices, which again is very different than what you were doing in the on-prem world. So another thing is, obviously, the more you scale out, the more the problems become complex and very hard to solve. Meaning, if you are running in a CSP with 2 or 3 VPCs, it's very different than if you are running with 300 to 400 VPCs. It's very natural with any network that grows. The challenges, the need for deeper visibility and better tool sets at your fingertips becomes much more critical. So coming to infrastructure as code is mainly we focus on Terraform. But the whole idea is that instead of going to the UI and having to create infrastructure and make configuration changes to it, you can codify, or you can basically write how you want your infrastructure to be in code. The advantage is multifold, where number one, it's very much standardized, meaning that if you wanted to spin, for example, 6 environments that need to look the same, you can use the same code, and this will ensure that these environments are exactly identical, which is a huge benefit, because whenever you give a human a task and tell him to repeat it, him or her to repeat it a few times, you will notice that there generally are differences with humans, right? We might miss something or add something or change something, or we might want to try something. So whenever you codify infrastructure, that gives you that advantage of consistency, that advantage of homogeneous environments across the board. The second one, obviously, is now you can tear down and spin up infrastructure, which could be something, I mean, tearing down probably might be useful for mostly dev environments. And the fact that you have this flexibility of, for example, if you get you get a malware, or you get exploited in one of your environments, you can go to a completely different segregated account and leverage that account and spin up, leveraging code, all the infrastructure that you had spun up. Obviously, you still have to deal with managing data and how you get that. But whenever your infrastructure becomes code, it can also be thought of as part of the high availability strategy, because you can go and spin up everything that you had in your previous environment just by running the code. Yeah, I think one of the points is, I mean, one of the advantages of infrastructure as code and generally Terraform is the fact that it's idempotent, meaning Terraform tracks the state of the infrastructure. So if you tell it to create, for example, an instance, and you run the code, it goes and creates the instance. Now, if you go and run the same code again, it will notice that this resource that it has in its state is still existing. Thus, it will not go and create another instance. Only if you go and, for example, add another instance to your code, it's the delta that will actually be created. So Terraform maintains the knowledge of resources in a database that is called state. Okay, so let me show you, I think, instead of looking at the slides, let me show you a bit on the Terraform provider. So a Terraform provider, you can think about it like, it's like a function. I mean, it's like you are getting the function definitions in order to be able to create resources for that vendor. So whenever you go and use the provider, you need to go and say, I want to use Aviatrix, so I want to communicate with Aviatrix. And very importantly, you will see that there is a version. Now, whenever you talk about versions, there is always a compatibility chart. So if you open the compatibility charts, you will notice that for every version of the provider, my apologies, I was saying that for every version of the controller, there is a version of the provider. For instance, if I look at my controller, I can see that it is running 701.768. And I look and I say, you know what, it's 701, then this probably will be Aviatrix provider version. If once I upgrade to 7.1, I'll have to run 3.1. Okay, so this is very important to maintain a one-to-one compatibility or a one-to-one mapping between whenever you're running Terraform and you have an error that seems to have to deal with provider versions. Just make sure, look at your controller and make sure you have the right version, which you will need to specify here by the version under the provider. The next thing you will need to do, now that you said, hey, please, I want to deal with Aviatrix and please get me that version because I have a controller of that particular version. The next thing, which is very, very logical, is you want to tell it where is your controller, right? Because if we are going to do Terraform, basically we need to do Terraform against the controller and ask it to spin up these resources. So it's very logical that we will need to give it the IP address of the controller, its username and password. There are ways in Terraform that if you do not want to have this as text, as clear text, you can have it as a variable, and then anybody can use the code. They will just need to manipulate their variables. And this is even a better practice because it avoids having the username and password in the code itself. Okay, so this is about everything you need to do. So you say, I want to communicate with an Aviatrix resource, or I want basically to Terraform against Aviatrix, and this is where my controller is, and this is its credentials. So I think I'll show you some very simple examples. Now, if you go to what's nice also about the Aviatrix provider, first it's multi-cloud, meaning that you'll be able to spin up with the same provider resources in multiple CSPs, but it's also structured very similarly to how we structure our controllers. So if you look at, there's a gateway menu, there is a gateway menu. Under the gateway, there is multi-cloud transit. There is also multi-cloud transit. There is TGW orchestrator. Sorry, you will find the TGW orchestrator. Useful tools can also be found here, right? So whatever you have, it's structured in a way that if you're used to the controller, you know where to go. But we can even make it simpler. So I want to say, I want to create a spoke gateway. So I say, you know what, Aviatrix spoke gateway. So what's nice is it gives me examples. So if you want to create an Aviatrix spoke gateway, you want to put this syntax, okay? The cloud type, if I don't know what this is, I can go and search. If I go down, these are all examples, but if I go under cloud type, it's a required parameter or argument. Basically, this is one that you cannot miss because, I mean, because it mentions this is the type of the cloud service provider. We need to know if it's AWS, if it's GCP, if it's Azure, OCI, Azure Gov, AWS Gov, all of these. That's why this is part of what makes it a multi-cloud Terraform provider, is that by changing the cloud type, we can spin up a gateway either in AWS or GCP or Azure and so on. Okay, so every parameter that we have is documented. This was cloud type. The account name is nothing but the account name, right? Remember that whenever you onboard accounts, you give the account a name. So this is referencing what you want your account name, or basically you want to spin up a gateway in AWS because you have put the cloud type 1. What is the account? Because you can have multiple accounts that you have onboarded and you want to spin up that gateway within a single account. So you will say the account name is this account. What is the gateway now? You can just specify any name. What is the VPC ID? You can either give it as clear text, or if you created the VPC, you can reference that. Becomes a bit more complex, but again, possible. Which region? Because whenever you say, you'll have to specify in which region is the gateway. And what is the gateway size? What's the subnet? And some other, do you want HA or do you want NAT? And if I show you how, when we create a gateway on Copilot, you realize how much this is the same. If you go to gateways and you go to a Spoke gateway and you add, right? First thing is, obviously, you need to give the gateway a name. That's the third parameter. The next thing, after you do that, you will need to decide which cloud type, which is exactly this parameter. And then assuming that I have AWS, I only have one account in AWS, but if I have many, I could choose one. This is what the account name is all about. Then notice that obviously I have to select the region because the VPC is a regional construct. So we say region. So I'll have to select, for example, US East 1. Now I will see the VPCs because I will need to spin up the gateway within a VPC. And this is what the VPC ID is all about. So I will choose this VPC ID. The instance size is nothing but the gateway size, which is T2 micro, which is again T2 micro, right? I just try to show you how simple this is and how similar this is to how you create things. So if you just copy this, it will go and create the gateway for you, assuming obviously you have configured the provider as we have seen, and you have managed the compatibility between the controller version as well as the Aviatrix provider. Okay, next I'll just show you a very small code that is on my GitHub. Again, I've documented it some time back, because if you look at the version, but what's nice about it is it builds all of this setup, meaning it builds the different 3 VPCs. It builds a workload in each VPC. There are some of the VPCs have a single gateway versus others have dual gateways. They all connect to dev and prod connect to a pair of transits, which also have a pair of Palo Alto firewalls, and then they are paired with another pair of transits. And there's also a CSR router simulating on-prem that also gets connected to them via site to cloud. All of this gets instantiated for you. And the way I've done it is also very easy. All what you need to do is to fill up the variables. So let me show you what I'm talking about. There is a file. Again, this is a standard in Terraform, is to use a variables file. So instead of me having to go and write everything, I say, you know what? This is the variable, Aviatrix controller. This is how, if you go and you have your own setup, you'll have your own controller. So you will go and put your own IP. Same thing, you'll put your username for the controller, the password, by just filling these 7 variables up till this moment, till the home IP, which is the IP of your IP, your public IP, so that you're able to access the setup. Once you fill these variables, the whole setup will work for you. And the beauty of it is that anybody can take the code, adjust it to his own parameters, and they will get an environment that works for them. Instead of me hard coding all of these values, I variabilize them. I make them variables, and then each one can adjust the setup for them. So I'll just show you how easy it is to do. The first resource is the Aviatrix account. This is, by the way, is basically a way to onboard the AWS account on my controller, which is exactly what we do with this. If I were to add this, I am doing this via Terraform. So, and if you're wondering how am I doing this and is it complex, you can go and say, I want to add a Aviatrix account, and you can see an example of how it is actually done. And you can copy it because this is how I've done it, and I make some changes to it. But if you look at this, and sorry, let me get this here. If you look at here, you'll find that it says cloud type, it has AWS account number. Just look at exactly the same thing. AWS IAM, true. The role and the EC2, I have variabilized a bit, but other than that, that is everything you need to do. It's just merely, for the most part, it's a copy and paste. Okay, and then there's something called modules, which is if you look at the Aviatrix here, if you go to registry.terraform.io, okay, and you just search Aviatrix, you'll see two things: provider, which is what I was showing you, but you can also go to modules. So modules are generally a way to bundle multiple things together. For instance, if you look at the Spoke module, it will deploy a Spoke. However, when it deploys a Spoke, it will deploy a VPC, it will deploy the subnets, it will deploy the Spoke, all of this. So it's an easy way. You can think about it like a function in code. Somebody wrote a function that will spin up all of this stuff for us, and then we can go and utilize this function and get it to run easy. And for example, if I want to do a greenfield Spoke in AWS, I can just go and copy this code. And this is exactly, if you look at my code, you'll see that it's almost a copy paste. So let's look at the Spoke, for example. This is the module, the Spoke. This is exactly the same. It says the cloud is AWS, the name, the CIDR. This will create the VPC, as I mentioned. The region, account. It's exactly the same thing that I've mentioned. The transit gateway, meaning which transit gateway do I need to connect to? Again, as I said, I can reference. Maybe this is something you will learn when you start experimenting with Terraform, but just if you can see it, I say transit gateway is module.mc transit. If you look at this, you will find that this is what it's referencing. So I'm saying I want to connect this Spoke to that transit that was there. Okay, and this will do the attachment between the Spoke and the transit. Okay, I just wanted to get you, for example, you want to have transit peering. You will put the name of the first transit gateway and the name of the second, and we will automatically peer the two transit gateways together. Again, what's nice to understand is that Terraform is not only about Aviatrix. You can create the whole AWS, even the virtual machines, everything can be done in the same manner. I won't take you through all of this, but if you want, for example, you can go back and say, you know what, take me to AWS. And again, I can use the same thing. There is a provider. You can go documentation, how to use the provider, and then you can just specify the region that you would like to actually do it. Again, there are ways to authenticate access keys and secret keys and all that stuff. But then if you want to, for example, launch an EC2 instance, if I this is an EC2 instance. This is a full example in order to launches an EC2 instance, and they are using an AMI that they filtered for. But you can take this as is, and it will create for you the instance. If you want an example with network like this one is going to create the VPC. And by the way, if you're wondering, you can say VPC here. And if I go to AWS VPC. Oh, sorry, this was the data resource. Apologies. So what I'm going to do is I'm going to do AWS underscore VPC. App mesh does not make app runner. Yeah, resources, there's a section called VPC. And if I go and say AWS VPC, if I just write this will create the VPC for me. If I want, for example, a security group, this also explains how to create a security group. Again, all of these are documented. And I just wanted you to get a feel of Terraform. We also have a course which is about the automation specialty or infrastructure as code that I would urge everyone to have a look at. The course, I believe, is available on ace.aviatrix.com. If you go to this is where the ACE Academy, and you can go to on-demand trainings, and you can find the ACE multi-cloud network automation specialty. Okay, this is a beginner course that is around 4 hours that teaches you the basics of Terraform. And this is where I started, and I never came back to use the UI. Everything I do is now based on Terraform. It just makes everything much simpler, and I destroy my labs when I'm done with them. Okay, so I think I've walked you through some of these. I explained modules. This was just an example of a module for transit, and it shows you that it's creating both of these transit gateways. I think that was a good introduction to Terraform. Another topic is the controller high availability. One very important piece of information to always remember is that the controller is not, my apologies, the controller is not in data path. So if your controller goes down, the data plane continues to function fully. Your network is going to still be up and running. The only thing that gets affected, just to be 100% accurate, is user VPN, only for users that want to authenticate. Because if you remember, no matter how you're doing authentication, there is for example, your IDP example, Okta needs to return back to the controller and say, hey, you know what, this user authenticated and he belongs to the profile so and so. If the controller is down, that new user will not be able to authenticate and be on the network. Apart from that, any connected user that already connected will not be affected. Any data plane traffic will also not be affected. So it does take a few minutes to switch over to the new controller. Again, the reason is this is very much acceptable is the fact that there is no data plane impact. So the way it works, I'm going to explain AWS. We also have similar mechanisms in other cloud service providers. So the way it works is in AWS, we leverage a functionality called autoscaling group. Think about it like a controller, okay, or basically a software component whose goal is to ensure that there is always one virtual machine, one controller virtual machine that is running. So this is what you define in the autoscaling group. You say, I want to always have a single controller. Whenever the controller goes down, that software component is going to say, oh, wow, I no longer have that. I no longer have that desired capacity of one. So I'm going to spin up a new controller. However, this controller now is completely blank, meaning it's a new controller. It doesn't have any configuration, doesn't have any state. So how are we going to get all of that configuration on the controller? So we leverage SNS, which is a notification service that triggers a Lambda. A Lambda is nothing but a function as a service. You can look at it like it's a place that whereby you can run code without managing servers, right? It's serverless. It's a serverless, or it's a function as a service. So the goal, the objective of using the Lambda is to run a code. The code is going to go to S3, which is the object file storage service within AWS, because this is where the backups are stored. And it's going to fetch the latest backup and push it to the controller. This will mean that now the two controllers are identical. Okay, again, we always urge you, I mean, we're going to take backups in an automated fashion. And if you have any change or any event, we can also take a manual backup. So whenever we go to fetch, we always fetch the latest backup and push it on the controller. So now the old controller and the new controller look exactly the same. And this is how we do the HA process. Another important component of operations is always upgrades, right? So a few points to remember for upgrades. Again, we stress the controller is in the management. It's a control plane. What I like about the upgrade process, it's one of the smoothest upgrade process that I've seen, and it's generally hitless. It's much faster than on-prem upgrades for sure. A data point that we gathered from a customer is that we were able to upgrade 500 gateways in approximately 22 minutes. My apologies. So you can perform the following operations on the gateway. Generally, what we always recommend is always do, by the way, I mean, there are two components. When we talk about the platform, we're talking about the controller. When you're talking about the gateway, it's the data plane. But we always, for both, recommend using a dry run. It's a way to check if the upgrade will succeed or fail. And it does check a lot of things like CPU, memory, storage. Can we reach the upgrade server? What's my health before going and getting the upgrade? So if you do the dry run and you see that, hey, yes, I mean, we're looking good, it hopefully, most likely will be that it will be a successful upgrade. If you see a dry run that does not show a positive result, please make sure that you do not continue, and you can open a case with Aviatrix to understand what is happening. Okay, so again, the platform is the controller and the gateway is just the gateway. So you do the dry runs. If everything's looking good, this is where you can upgrade the platform software, the controller software, similar to the gateway software. If you're not happy on the gateway software, you can always go back, roll back the gateway software. I mean, one thing I cannot stress enough, across my 15 plus years of IT experience, always test your code. And I always would recommend to have a staging environment. No matter how good the code is, no matter how good the engineering team is, no matter how good the testing we do internally is, I always suggest it, because every environment is different. If you have a staging environment, you are saving yourself money and time by not falling into a problem and causing yourself outages and pain. So I always recommend a separate staging environment where you can test the features, you can test the upgrades, you can make sure that everything is looking good before you go and push it to production. As always, suggestions, I mean, we always recommend looking at release notes, making sure you understand the caveats, I mean, of the release that you want to move to. There is some on our doc site before upgrade, some operational procedures. And then if you've done all that, you've staged, you're happy, everything is looking good. We also always recommend the dry run. And as I mentioned, the dry run is looking at the reachability between to the release server, the reachability to the gateways, the free memory, the disk space, and the CPU. If all is green, this is where you can proceed with the upgrade. You can always visit support.aviatrix.com to open tickets, look at some knowledge-based articles, documentation, and other elements. You can also configure the different, basically on different events, who do you want to receive those events? Meaning some of these could be security events, CVEs, vulnerabilities that we are aware of, and we want to make sure that we send it to the right team or the right distribution lists so that we notify the right people. There are certain things that are, I mean, for critical alerts, status change, or I mean, account and certificate alerts, you can put multiple aliases depending on who is responsible for what. And then one last thing to mention, maybe not really directly operations related, but if you do not have an Aviatrix environment and you would like to have a small lab for yourself, I would suggest that you look at the Sandbox Starter tool. It's a very cost-effective and simple way to basically play and get to feel the Aviatrix environment. It's really again, what we're showing here is just the cost to operate it, and you can see that it's very individual friendly. We're talking about less than $30 to have it up and running for 24 hours. Again, as always, generally, especially if you're doing it in the lab, make sure that whenever you are not using it, at least you're turning it off so that you are not paying for those instances in an active fashion. So again, the Sandbox Starter tool is a turnkey solution to deploy the controller to deploy a small architecture or a small setup in AWS and Azure, including test instances, and gives you a feel of the Aviatrix solution. The most common way to deploy it is leveraging an AMI. So what will happen is you will deploy the Sandbox Starter tool AMI, and then this Sandbox Starter tool AMI is the one that will launch the controller, configure all of the stuff from security groups to it will onboard the AWS account, key pairs, security groups, and a lot of stuff. It will also launch the gateways in AWS, in Azure with the respective transits. So basically, it's a really nice way of getting started. Even before I joined Aviatrix, I used the Sandbox Starter tool to get a feel of how the solution actually works. Sandbox Starter tool is also based on Terraform. There are two modes. There is standard and advanced mode. If you are getting started, I would suggest to stick to the standard mode. And then when you become a bit better at it, then you can switch to advanced mode. It allows you to customize things like resource names, like CIDR blocks and regions. What's also nice is you see the destroy button on top. If you click that button, that will actually destroy or delete all the resources that the Sandbox Starter tool has created. So this is the setup from a topology perspective. You will see that it launches two Spoke gateways with two virtual machines in AWS, as well as the controller, with a transit gateway. Now, this is one option, and you can still extend the setup into Azure, okay? And you'll be able to do pings from these instances and try different things. Okay, this is what you need to give it the AWS credentials so that it's able to spin up all the resources for you, and then it will launch the controller, the transit, the EC2 instances. And what's nice is once it's done, it gives you the IP address of the controller, as well as the private and public IP addresses of the virtual machines for you to be able to SSH and test some things and make sure that traffic is flowing.